Hi everyone. The purpose of this video is to show you how to solve polynomial inequalities and rational inequalities. So it's following up a little bit from what we did in class. So polynomial inequalities are basically when you have a polynomial expression and you want to find if it's greater than or equal to, greater than, less than or equal to a number, when it is, what values of x will satisfy the inequality. So this worksheet kind of takes you through all the steps that you need to solve them. So questions 1, 2, and 3 just say to identify the zeros. Remember, zeros are just x-intercepts. And x-intercepts are going to be what makes the expression equal to 0. So for number 1, because it's in factored form, the expression is in factored form, we can say that the zeros are 5 and -2. Those are the x-intercepts. With number 2, we can say we have x here, so 0, 0, -7, 0, and -4, 0. These are the x-intercepts or the zeros of this expression. And then number 3 is a little trickier, but it's doable. X cubed, what would make x cubed equal to 0 when x is 0? 2x minus 5, what value of x would make this whole factor equal to 0? Well, we could take 2x minus 5, set it equal to 0, and solve for x, and we get that x is 2.5. So those would be the zeros. The next thing is just remembering what happens when we multiply negative and positive numbers together. So we're going to get to why we're doing that in a little bit, but if you multiply a positive times a negative, it's going to be negative. If you multiply a negative times a positive, that's going to be a negative. And that's going to come up in this objective a lot. Here we have negative times negative, which is positive, and then that times a positive will also be a positive. And then last we have a negative times a negative times a negative, right? A negative times negative would be positive, positive times negative would be negative. So usually if you have an even number of negatives, you'll have a positive. If you have an odd number of negatives, it'll be negative. So here we had 1 negative, turn the whole thing negative, 3 negatives, negative. So that's one way to think about it, but you can also just think about it step by step. We did number 5 and number 6 in class. So I'm just going to do number 7 as an example to kind of help you through it. So these are just like some practice problems. So the reason why we did those exercises in 1 through 4 was to help us get to a point where we can solve the inequalities. So the way that we solve the inequality, you could do it by graphing, you could look at it, but we're doing it through a sign, like a sign diagram. So we're looking at a number line, we're looking at what the x-intercepts are, and we're really going to figure out for what values of x will this be true, right? And then we'll state what those values are, right? Because an inequality means that it's not just one number that's the solution, it's a whole interval of numbers. So first we need to find the zeros. That's why we did that in steps 1 through 3, just to refresh our skills in finding the zeros. So the zeros are, I see 2, I see -1, and I see +6, right? Because 2 minus 2 would be 0, -1 plus 1 would be 0, and 6 minus 6 would be 0. I want to write them in order just to make sure I stay organized a little bit. So I'm going to write them as, I'm going to have -1 here, I'm going to have 2 here, and I'll put 6 here. And then the real work, and it is a lot of work, is to test some solutions that are in those sections to see if they're positive or negative, right? Because the task is to find out where this expression is greater than or equal to 0. All right, so let's just test. I try to find the easiest numbers I can to test. So here, let's test -2, because that's less than -1. Here, let's test 0. That's between -1 and 2. And here, let's test 3. That's between 2 and 6. Okay. And I have 1 factor, 2 factors, 3 factors. So, oh, and I have to test something after 6. So let's test 7. So I have 3 factors each time, and I'm going to test them to see if a negative or a positive solution comes out, right? Because I know at -1, at 2, and at 6, I am at 0, right? But we're looking at like, where are we also greater than 0? Where are we positive? Okay. So I'll test -2. So if I plug -2 in for x, what's happening in each of these three factors? So here, -2 minus 2, that's -4. So this right here will be negative. Okay. -2 plus 1, that's also going to be negative. -2 minus 6, that's also going to be negative. So negative times negative times negative. Why did we do that, right? It's negative. Okay, so this is negative. All right, let's test 0, right? That's our next job. So 0 minus 2 is negative. 0 plus 1 is positive. 0 minus 6 is negative. So negative times a positive is a negative. Then a negative times a negative is positive. Okay. All right, now let's test between 2 and 6. So we said we're going to test 3. 3 minus 2 is positive. It's 1. 3 plus 1, positive. 3 minus 6 is negative. Positive times positive is positive. Positive times negative is negative. So this section is going to be negative, below 0. Okay, and now we'll test 7. So 7 minus 2 is positive. 7 plus 1 is positive. And then 7 minus 6 is positive. So this will be, without a doubt, positive. Okay, so I'm looking for where the expression is greater than or equal to 0. So that is going to be positive, right? Greater than 0 means positive numbers. So because it's greater than, I'm going to choose positive, the positive intervals. And because it's greater than or equal to, I'm going to do these hard brackets, right, around my solutions. So we did soft brackets when we had no or equal to, right? It was just greater than or less than or whatever, right? So this is like soft, like parentheses. But when we have or equal to, we're going to use these square, more square looking, harder brackets. So let's go ahead and write our solution out. So positive, when is it positive or 0? From -1 to 2, and then again from 6 to infinity. So I'm going to write my answer as hard bracket, -1 to 2 in union with 6 to infinity. And I always do soft brackets around infinity because you can't really touch infinity, right? But all the integers, all the x-intercept values get a hard bracket. Okay, so that is the number line sort of sign chart way of solving your inequalities. So basically, these are the x values where this is true, where this expression is greater than or equal to 0. Okay. We're also going to do one where we're dealing with rational inequalities. So rational, right? We have like fractions with x's in them, but it really is the same idea. You're still finding the critical values or the x-intercepts and the vertical asymptotes. So here we know we have an x-intercept at 1, 0. So 1's definitely going to be a part of our deal here, right? And then we're also going to have vertical asymptotes at -2 and +2. So we're going to include those in, I should say x equals -2 and x equals 2. We're going to include all of those in our sign diagram, our vertical asymptotes as well. So let's go ahead and make it. We need to put -2 in, we need to put 1, and we need to put 2. Right? And then we have to test around it. So we'll test, I'm going to test -3. I'll test 0. I'll test 1.5, and I'll test 3. All right. I don't know why I put that -3 in parentheses, but I did. Okay. So just like here, we set it up as like multiplied factors together. I'm going to set this up the way it is with the equation, with the expression. So I'm going to have blank over blank times blank, blank over blank times blank, blank over blank times blank, and blank over blank times blank. So I'm just going to really just keep this structure, this factor divided by this factor times this factor. And we're just going to determine if it's negative or positive. Okay, so if I do -3, if I test -3 in here, -3 minus 1 is going to be -4. That's a negative number. -3 plus 2 will be negative. -3 minus 2 will be negative. So that's going to give me negative over positive, which will be negative, right? So I'm going to put a little negative right here. So when this expression is less than 2, when x is less than -2, the whole expression is negative. Okay. Here we'll test 0. So 0 minus 1 is negative. 0 plus 2 is positive. 0 minus 2 is negative. So that'll be negative divided by negative or positive. So my function will be positive from -2 to 1. Now I have to test a 1.5, which is a little annoying because it's a decimal, but we're going to get through it. 1.5 minus 1 is positive. That's positive 1/2, right? 1.5 plus 2 is also positive. It's positive 3.5. And then 1.5 minus 2 is negative. So here we have positive divided by negative, which will be negative. So right here, we have negative. All right, and then lastly, testing 3. 3 minus 1, positive. 3 plus 2, positive. 3 minus 2, positive. So this is positive over positive. So this is going to be positive. So the actual question is, when is this expression, for what values of x is this expression less than 0, right? So that's going to be here and here. Less than 0 means negative. So my solution set will be -infinity to -2, right? And then again from 1 to 2. And because it's less than and not less than or equal to, I don't get hard square brackets with right angles, I get soft brackets. So I'm going to write it as -infinity to -2 in union with 1 to 2, and that's it. Okay. All right, I hope this video helped you understand a little bit more about how to solve polynomial inequalities and rational inequalities. If you have any questions, please let me know. Thank you all so much for watching, and I will see you next time.